Dr. Kannan sir, good evening. Good evening, sir. Kannan sir, good evening. Welcome.
Good
Welcome,
evening,
sir.
sir. Welcome.
Welcome.
Is it my background is okay?
Yes, sir.
My background is okay.
Yeah. You are well experienced. I saw it. I saw your profile. Nice to see your profile.
Thank you.
Nice to interact with you today. Really, we are very eager to hear your visionary talk. That's what.
Yeah, thank you, sir. Thank you.
You have been given the rights. You can just test it. Just PPT வருதா என்னன்னு பாத்துங்க.
Is it okay, sir?
It is coming. Make it full mode, sir. It is PPT mode. Make it full mode.
Yes.
It's okay, sir. Now we'll wait up to 5:30. People are joining. We'll start at 5:30, sir.
Okay.
Okay, sir. Nice. Thank you, sir. Thank you.
Okay. Sorry. Thank you. Oh, God. ஆமா, ஒண்ணு செய்யுங்க. இதை தூக்கி கொஞ்சம் அங்க வச்சுட்டு கொஞ்சம் தூரமா இல்லைன்னா இது இங்கே இருக்கட்டும். அந்த இதுல இருந்து கொஞ்சம் மறைச்சிக்க வர்ற மாதிரி கொஞ்சம் இன்னும் பின்னாடி அந்த இதுல அந்த இடத்துல அப்படின்னா ரொம்ப வராது. தெரியுதா? இல்ல இங்கதான் வைக்கணும். இது ரொம்ப க்ளோஸா இருக்கு. இதை நகர்த்திருங்க. தூக்கி அந்த பக்கம் வச்சு பின்னாடி அப்படி வச்சு. ஓகே. Okay, good. இதை கொஞ்சம் ஓபன் பண்ணுங்க.
Yes, sir. Dr. Kannan, sir, will start the program, sir. Thank you, sir. We will just start.
Yeah.
Happy good evening. Yes, sir. With your consideration. Happy good evening to everyone. Today we have an interesting talk. That is, revisit to product design and manufacturing in the foreground and of 3D printing technology. This is going to be delivered by Dr. M. Kannan, Professor in Charge, Innovation and Product Development Center, Francis Xavier Engineering College, Tirunelveli. Today, in today's context, this 3D printing plays a major role. That is one of the pillars of 9 pillars of Industry 4 as well as smart manufacturing. Without 3D printing, we cannot think of even our BHL boiler. Turbines are being printed by 3D printing. From small component to big components, such a thing is going on in fast way. In so many, compared to the additive regular manufacturing, the additive manufacturing saves the material lost. Almost near to the safe of the material, we build it and machine it and to record. That is a saving, great saving for the today's industry scenario. That's what cost cutting is one of the important component in today's life. First of all, we thank Dr. M. Kannan, the professor, for accepting an invitation to deliver the talk to our platform, sir, for IAE members. Thank you so much, sir. And we welcome you to IAE platform, sir, IAE platform. And as far as today's program is concerned, Institute of Engineers Trichinopalli Local Center is in association with Safety and Quality Forum of New Delhi, Computer Society of India Trichy chapter, Indian Institute of Building Trichy branch, Indian Institute of Metal Trichinopalli chapter, Indian Institute of Industry Engineering Trichinopalli chapter, Indian Society of Non-Toxic Testing Trichinopalli chapter, Indian Welding Society Southern Zone, and Kumari Arivel Ferry are joined with today's program. And for the past, actually, we IAE Trichinopalli Local Center, for the past 3 decades, without interruption, we are conducting Tuesday program. Before pandemic, it was in physical mode. We have a very big auditorium hall, lecture hall, and it is being given by the BHL management. And BHL is in big way promoting the professionalism. It is given by the great Kamara 3,000 acres campus, Trichinopalli. Our office is situated. More than 10 professional bodies, active professional bodies are working in this institution, this campus. And out of which we play a role model and we combine with the other professionals to conduct many technical programs. And this is our, before pandemic, it was physical mode. After pandemic, it restored to 168, virtual mode. This is our 168 program. In between, we did some hybrid mode also. So with this brief introduction, I call upon Mr. Engineer Lakshmanan, our present committee member representing electrical division, as well as the Powerman honorary secretary. When I was chairman, he was secretary. I request him to introduce the speaker to the audience. Over to Mr. Engineer Lakshmanan, sir.
Good evening, sir.
Yes, sir.
It is my privilege to introduce today's speaker, Dr. M. Kannan, Professor of Mechanical Engineering, designation Professor in Charge, Innovation and Product Development Center, Francis Xavier Engineering College, Tirunelveli. Academic qualifications, Jadavpur University, Kolkata, PhD Engineering. Degree awarded in May 2010. Thesis under Professor Dr. J. Tirmai Saha, entitled Design and Analysis of Reconfigurable Machine Tools. PhD College of Technology, Coimbatore. Master of Engineering in Computer Integrated Manufacturing degree. 7.66 CGPA first class, awarded in February 2001. Thesis under Professor Dr. P. Radhakrishnan, entitled Algorithms Development for Virtual Pocket Milling. Tyagaraja College of Engineering, Madurai. Bachelor of Engineering in Mechanical Engineering degree, 65.68%. First class, awarded in April 1998. Teaching experience in 21 years at various capacities. Area of specialization, CAD and product design development. Achievements, winner of MSME Hackathon 1 and got a grant of 12 lakhs for dual axis solar tracker for heavy load solar converter. Received a fund of 30 lakhs from NABARD under district My Project towards technological intervention for pottery cluster. Government funded research project sanction of rupees 9,68,000 from AICTE under Research Promotion Scheme RPS sanction order 20 AICTE RFID RPS policy 322/2012-13 consultancy work of worth rupees 10 lakhs undertaken for Ashok Leyland and Sandhar Automotive. Government of rupees 6,55,000 for organizing various and conferences, published 25 plus technical papers in international journals of International Journal of Vehicle Structures and Reviewer of ASME Journals Mechanical Engineering, establishment of Center of Excellence, Center for Virtual and Advanced Design Studies at a cost of 1 crore at SKP Engineering College, Tiruvannamalai. Recognized the Anna University Research Guide. Organized an international conference, ICD AAME 2011, which attracted 600 plus technical papers under 9 heads with a participation from Government Research Institute, IITs, NITs, and international participation from all continents. Years of experience, 21 years. With this introduction, I request today's speaker to take the lecture program today.
Thank you, Lakshmanan. Thank you, Lakshmanan, for nice introduction. I over to Dr. M. Kannan, sir, for your delivery, sir. Please, sir.
Yeah. I really very much grateful to deliver a lecture on this kind of IE forum. And it is not new to me. I already visited the center and delivered lecture in physical mode also some 2-3 years back. And I would like to thank all the organizers and the personnel who are all cause for making me to share my experience here. Without a delay, we will start our lecture. And before that, I would like to know how long I can take, sir.
So 1 hour, sir. You can take 1 hour, sir.
1 hour. So it is 5:40
and followed by 15 minutes question answer, sir. Then will be vote of that, sir. Followed by. Okay, sir.
Yeah, thank you. So I'm sharing my slides and we will.
Yes, sir. Please, sir. Please, sir. Yes, sir. It's okay, sir. Okay, sir. Again, go ahead, sir.
Right. So today topic is much of interested because 3D printing technology is unavoidable now, and any technology will impact on the products that the humankind will use. And similarly, this 3D printing technology also have a very higher impact on the design. That is what we are going to look into. It is even the topic can be looked into two perspectives. One will be connecting with the design, and the other will be connecting with the manufacturing. So it is a perfect combination of topic so that we will get the benefit out of the technology. So my presentations will be like this. We will have a small review on 3D printing technology, and then I will set up the background for taking up the 3D printing parts designs. So in that setup, we are going to discuss about different 3D printing technologies available and their capabilities and capacities, and the material range that we could go for making 3D printing parts, and then the part design ranges, the complexity range. And then we will have a small note on methodologies and the tools used for 3D printed products, and then finally we will take up on framework for the 3D printed parts. So it is even beyond the design for 3D printing. Rather, it is going to be an integral design method that we will understand, and finally we will have the concluding remarks. It is to set up only the background. So 3D printing is a process of making a three-dimensional digital model in a physical form using laying down many thin layers of material in succession. So it is not about only a filament based layer, rather it can be a metal, that is we will look into. And the printing technology will have this particular steps. For any 3D printing, we must have CAD model, and the model will be converted to a common file. There are number of additive manufacturing files are now being introduced, but still the very popular file will be .stl files. It is a tesselted, laminates, and this file will be then supplied to a software called slicing software or material preparation software, where it will be sliced, and the slices will be converted as a GD code, so that the printing machine will get print the parts. So this is the general process. And to know how it works it is a very basic 3D printing technology, and it is the earliest 3D printing technology. That is what fusion deposition model. So it will have this will have extruded, and that will be mounted in any of machine that will take motion in XY Z axis, or it can be fitted even in the robot. So it is going to act as only a throwing of material, and it can be fitted with any moving machine, so that we will get generated parts. So first of all, we must know, is it limited to only plastics? So that is not. So surprisingly, you can see that now 3D printing can be done with even Incal, the hardest material, and similarly we can even go for tool steel also. Is the size matter is a question? Then that also false. You can see that a complete speed coat hull will be printed by the 3D printer, and the size also you can see. So how large it is. So the size also not matter. And the capabilities, if you go for what you are seeing is a 3D printed heart, and in the other end you are having even 3D printing is used for even construct a home or a large structures. The other capabilities of 3D printing, now we are having a slicing algorithm that will do it in a multi-directional slicing. So it is not limited to any complexity of the parts. And all together, this parts information is converted as a G code. This is to tell the viewer, the listener, how the things are working. So this is very similar to a robotic machining or a CNC machining. Only thing, instead of tool, we are using a extruder, and there are other technology also there that we will see. And in associated with the 3D printing technology, we have a 3D construction technology in hands with. And this is where the designs will come into picture. So if you now the 3D printing technology has changed the whole scenario of design. In that case, all the parts or all the machines or equipment that are available can be redesigned or re-engineered. That will save money, cost, and operational cost. And for that, this 3D reconstruction technology is the one that will support. So you need not to have the 3D models, rather you can scan the model, and then the same can be easily converted to the CAD model, which can be printed later. So there are number of tools available for converting the scanned object into CAD models. So this is what something to show you how the 3D reconstruction technology will help you in capturing even a rocket nozzle. So now we will take a look over the 3D printing technology ranges. So I'm not going to cover up any of very basic a plastic based 3D printing machines. Rather, we are going to take upon a complete spectrum of 3D metal 3D printing technology. So now there is no limitation in usage of materials or things, and you can see that even sheeted lamination, the sheets will be cutted for the required geometrical aspects, and then they can be pressed and then applied a heat to get a complete part. So rather than only a fusion, now we are having even as sheet metal laminations or stereolithography. You can see that a selective laser sintering. So this 3D metal printing technology is completely changed the face of 3D printing technology. Earlier, it was only a prototyping technique. So here we are not going to talk about or see how the 3D printing machines are working and what are their working principle or the principle behind their machines. Rather, we are going to see only the spectrum of the metal 3D printing technology and how they are being used. And you can see that this is a pie chart showing how the 3D metal parts are being used. See here, a metal binder jetting is used mostly about 16% for direct part manufacturing, and similarly, a direct energy deposition method is another one that can be used. So you can see that resin paste is started becoming smaller in the usage of real-time product manufacturing when it comes to 3D printing printed parts. Someone is throwing up some scratches.
Unshare it and share it, sir. That will be all right, sir.
All right.
Yeah. Somebody is playing. Please stop playing on the screen. Somebody is playing on the screen. Yeah.
Right. And these are the other range of 3D metal printing and the pounded metal deposition, selective laser melting, or wire cut additive manufacturing, and even arc welding additive manufacturing are there. So you can imagine the range of product available for 3D printing. And this is the direct energy deposition method. It is plasmas for melting even a very hard material to get fused. And this is arc series lamination of getting a 3D print, and you can see that a complete wheel which is not having any of a separate parts and welded or joint. So even opto principle, lens principles are used to. The electron beams will be focused so that a very selective part with the selective material and microstructural composition can be manufactured. So here there are a high chance for controlling the microstructure. That is what we all must know, so that it is possible to sufficiently manufacture a product independent of materials. And this is to show a full-scale machine of a sonic technology. It uses ultra sounds to produce it. So sounds in the fusion, even the sounds are being used. And this is to show the process capability of a selective machine. And here I am taken SLS, a selective laser sintering machine. And you can see that the same machine can be used for product manufacturing by deposition method. The same machine can be used for coating or repairing of finer products, or we can use selective curing so that I can get a different inner shapes and so on. And so similarly, you can produce a complete part as well as a repairing or coating. So this is what the capability of a 3D printing technology now. And this is to spread out the spectrum of machine suppliers, and these are not different vendors. They are providing different kind of machines, and you can see that now earlier the 3D printing is having a limitation of speed. It will take a higher time to make it up any even a single layer. Now the speed also being addressed, and it has a chance of use of multi-material in the in the part manufacturing. So this will set the designer from the material size or material, or optimize the design for the strength. And this is telling you the different capacity of machines with the speed. You can see that the printing speed up to even 1524 per second is the speed. The temperature we can go up to 400. So these are all the capacity. The build volume is you can see that even 4 meter cross 2 meter cross 1.5 meter. So this is the range of machine size. So you can manufacture any size of parts or assembly together. The 3D printing technology also set aside not a part and assembly, rather it can be a part together, and a product together can be manufactured in single shot. That is the present capacity with 3D printing technologies. So this is the range to understand. So when it comes to material, and this will be interesting to see that even 316L alloy can be used, and they are all available in powder and filament form. Okay, if you go for any extrusion, filament extrusion method, or even go for selective sintering or powder metallurgical route. So this will set you, the combination of powder will set you a functional graded material also. And I'm giving you the the material and the supportive process here, the direct metal deposition, pinder jetting, direct metal laser sintering, okay, and so on. Even merging tool, you know that it is little high. It has a high strength and fracture toughness. So that can also available in powder and filament form, and the range of alloy is given here. The nickel paste alloy is also able to processed in direct metal laser sintering and fusion filament fabrication. So this is the technology. It supports carbon composites also. Even the toughest material and the biocompatible material like titanium also being used in many of the processes. You can see that the range it will support. It support most of the 3D metal printing technologies. And what you are seeing is in year 2018, the Pagati had developed a complete brake caliper with 3D printing machines alone, a whole assembly setups, and I can show you in the later part. And you can imagine how much the material being free of the design. The aluminum is again, it will support most of the processor, and the range of common alloys are given. So all the parts will be available mostly in both powder and filament form, except a few things. Here the cobalt materials is available only for powder form, and this will be mostly used in surgical and dental implants. Nickel alloys, and then copper paste alloys. Even the precious metals, you know that by India, the most of the economy relies on gold, and you can see that this can also be done. So this is setting up an independence on materials and even refractory material can also be used. So now we will our focus is on 3D printing, not on 3D printing technology. Rather, we have to see that how the this technology impact on the product development and the product manufacturing. So now I'm going to showcase some of the product that is manufactured with this metal 3D printing. And this is the baseline you all has to capture. The technology is not only transforming how things are made, rather it also change how things are designed. So that is where it is suitable for all the technology, and by knowing the capacity now, you all are able to appreciate the additive techniques, additive manufacturing techniques having a very transformative effect on the product design workflow. And you know that 3D printing is no more a product development tool. Earlier, it will be used to check only the functional, functionality of a product, how it works in a smaller scale. And sometimes it may be used for rapid prototyping, that is in making the tools and dies, right? Hereafter, they are not going to be only the product development tool or a rapid prototyping tool. So it sets the cost in terms of material saving, in terms of cost of the product compactness, and it also turned up manufacturing time. It also set design freedom for the design. And this is to lay out the different parts that are being manufactured. So part production distribution of 3D printing technology, you can see that there are about some 29% of parts, the functional parts are being directly manufactured using 3D printing. Whether it is in a polymeric material or in a metal things, are in composite material. And then fits and assembly. So you can see that. So this is the scenario. And it is to set up the 3D printing technology can also be considered and compete with conventional manufacturing. And you can see that when it comes to complexity, additive manufacturing has its highest impact or highest hand on in the manufacturing. Rather, when it comes to quantity, the conventional manufacturing methods will have the dominance. And you can see a sample part which is given here. Say there won't be any weld, or there won't be any machining operation to cut this the pattern. So the 3D printing machine gives an advantage of more complex design, reduced lead time, improved manufacturing efficiency, and higher quality parts in a single piece. That is what important. So the whole product can also be manufactured in single shot. And rightly, when we start, the president indicated that even the turbines cannot be thought of, the turbines even not being considered apart from 3D printing. So what you are seeing is a part, and you can see the complexity. So it is independent of not only the geometrical complexity, it also independent of all the machining process. So the part you are seeing is Epion casting and machining. And wherever possible, you can reduce the weight, and so the design is going to be very lightweight. And this is what very important. You can see that the manufacturing restrained design versus free form design. So what we are seeing here is something. The part shown in black is the conventional part being designed for the manufacturing restraint. So we know that it has to be designed for the either palming or casting capabilities, and then the machining capabilities, all will limit. The material must be a continuous one, and the machining must be consider different settings, and then it can be manufactured. So by considering all the design for manufacturing, design for assembly, the part will be designed with continuous material. Rather, what you are seeing at the end is a product that takes any form, but doing the expected function. Say here it is a slot, and the slot is being there, and it has to transfer the load, and it has to move on. So all the functional feature and also the structural requirement being no met, uh, uh, even after setting up huge material and even the set. And I already, indicated that in 2018, this is an award-winning design of a brake, a Bugatti, French automaker, developed using 3D printer for their supercar. And you can see the complete profile in a single shot, and it is a single part. And you can see all the complex shapes, curves running here and there. And this also providing a chance for housing different electronic parts and other parts too. That is what the beauty of this 3D printing technology that gives for the designer. And you can see that this is the very conventional brackets, and they are redesigned after 3D printing, and you can see that they are giving a lot of room for even housing of other parts, or a motor, or an electronic PCB ports, so that it makes the part very compact. And it also even we can think of mounting a motor at any point in the same part by developing a housing for the motor and the belt drives. So this is another scenario. You know that with the support material will be the one concept in the 3D printing. So by controlling the support material and the actual material portion, we can think of manufacturing and assembly in a single set. So what you are seeing is a hinge that is manufactured in a single set. So the material will be printed with the support material, and once the support material being dissolved using any post processing technology, or when it is removed, the part is will be able to do a function of revolving. All right. So the things are there to consider, the tolerances and others. So this will set a thought on the tolerancing too. And we know that that is the toughest part in design, and in the design part, right? And here this additive manufacturing even touch that particular critical point, and it makes easy that even we can have higher control over the tolerances. And here is another assembly. So I titled the game-changing assembly technology, because earlier the whole part designed revolves around the how the parts are being disintegrated and assembly to get a particular motion, or a force transfer kind of things. And there comes all the manufacturing and the manufacturing tool capabilities. But what here you are seeing is a completely integral part that is manufactured, and what you are seeing in between is the support material, and the part will be oriented in such a way that they are not crossing each that will be manufactured in a single 3D printing setup. Once these support materials are being dissolved, or it being removed using following any post processing method, finally your outcome will be like this. And this is what another thing. And earlier we know that when we put up a design feature in any parts, we have to consider it machining and its machining access direction and so on. But what you are seeing is, if you want to make this particular, slots, it has to be, set up in a different orientation, and the tool has to be controlled in 5 axis. Rather, in 3D printing technology, there is no restraint on the manufacturing setup or manufacturing tool approaches, as it is completely being eliminated in the design. So this product is purposefully put, and you can see that the holes of a very finer diameter to larger diameter can be done in a single shot. That is, this is what a product being considered as a test product for any 3D printing. So that is why it is being given. So the design for machining and assembly has only limited use in 3D printing technology background. So now, with this background, I listed different manufacturing capabilities of 3D printing technologies, and the part and the assembly capabilities, so that you can see that the part can be designed for any geometrical complexity and any combination of material. And similarly, the assembly also be completely can be the conventional pattern of assembly being questioned now. So with that background, we will go into the design methodology and tools being used in the 3D printed products. So the additive manufacturing or 3D printed product design will be set for freedom. So it has a complete design freedom from the manufacturing techniques in terms of constraint from the manufacturing. So design for machining, design for assembly being questioned here, and in terms of structural design also. It need not be only a specific material size and strength. Rather, the 3D printing can be adjusted, and the restraint, the part complexity and the ribs, internal ribs can be adjusted to get the sufficient strength for the structure. The other thing will be adaptability and flexibility. So 3D printing offers an opportunity to produce to get parts when you need it. That is what it is important. So it breaks the logistics, and so even anyone can think of all the part can be internally manufactured, so that we will have the control over the things. So supply chain management also, it is completely here and there. Have some limited something to be checked and revised. Then the simplification, and it has been, I am taken an example. So the General Electric Aviation, they created a helicopter engine with only 16 parts instead of earlier engine of 900 parts. So that is the impact a 3D printing technology will leave in the product design. And you can imagine the part consolidation is a very important technique hereafter in designing products. And similarly, it save time in terms of being in the process design and optimization. So as the parts can be clubbed and consolidated, so that the configuration design and the structural design can be in hand with each other, rather than now it is being practiced as a separate basis. So this is what change in scenario or change in scenes in the design I would like to tell to the viewers. So the topological optimization is a technique being have a great impact on the product design when it comes to 3D printing technology. And the material selection and structural optimization will be no more used in the news when it comes to the product design for the AIM, that is additive manufacturing. mass customization is possible, as once a part being created and customized, it can be printed in any numbers. So even single part or multiple part, now that being only the scaling up number of machines, not on the machine tool usage. Very importantly, the change in scenario is part consolidation. So any machine already existing can be now think of re-engineered or reverse engineered to get them a more efficient or more power saving equipments, or operational cost can also be reduced. The manufacturing cost can also be reduced as the number of parts comes to. And the other thing will be a lattice structure, and you know that this is the very high strength geometry that will prepared by the law of nature in designing any biological creatures parts like our cone and so on. So this lattice structure in the conventional manufacturing or the conventional design, it is not being or never been considered. Rather, AM technology given the chance. So these are the different scenarios that is being possible with AM technology, and that will change the design scenario too. So clearly, what I want to emphasize on design optimization is now being no use in the foreground of additive manufacturing, because you can see that the additive manufacturing metallic structure with the same macroscopic shape and size can be fabricated by different process parameters, having strictly different microstructures against the mechanical property. That means, so the structure is independent of material, rather by the controlling the process and the risks being used in the design. Any structure, the strength can be the necessary strength, and the property can be created or designed in the manufacturing itself. So that is what very important. And as we are going for selecting a selective laser sintering or a powder metallurgical sintering or fusion deposition, we are going to control over each and every point. And in the each and every point, what is the material being deposited, or in what combination it can be deposited, and what density it can be deposited, are all controllable in the 3D printing technology, so that the necessary mechanical properties or strength can be brought in. So the technology used is multi-scale and multi-physics integrated computational material engineering. So this is going to be the futuristic material selection process for the products. So I'm not going to talk about design for additive manufacturing that talks about overhangs or bridging, something like our support material or number of layers and so on. Rather, we are talking about the product in the whole product development and the manufacturing. So beyond the design for additive manufacturing, and now you to understand from my earlier discussion, the design style is completely free from any constraint, either geometrical based or manufacturing shapes. So broader choice of shapes and configuration are being now open up for the product designer. Similarly, you can even think of fabrication of linked geometrical complexity, so that one-step manufacturing is possible. Similarly, when it comes to structural material, it is suitable for any advanced composite or functional grade materials. Okay, so the material strength is not being considered, rather only the product requirements or the load requirements will be considered. Only the topological optimization will be the one that support here. So this is the design volume, and this is the load that comes in. So it can build up the material according to the stress flow. And if required in a particular point higher strength, it will build up material, or the density will be changed, and accordingly the same structure can be printed. And very importantly, and the structural mass fraction, that is where is only wherever you want, you can minimize the structural weight, and wherever required, you can increase the strength. And the thing is, we can go for optimizing both configuration and the part topology. That is where it comes in support of assembly technique. So reduction of part by consolidation of part is the technology that we must focus for the design of products for the additive manufacturing. The new fixing things has to be evolved, and the fabrication technique, that there are ranges. So now the question being changed, right? Rather than the part, assembly or machining constraint, now it is a question of how the part being, partitioned for the limitation of the available material scale. Okay, if the platform is supporting only 1 meter and your product is 2 meter long, how I am going to split the part and manufacture it? That is the question. Then how it is being machined, and how it being scheduled, or how it being processed. So the AM suitability will comes in terms of value analysis, because we can re-engineer any product, any parts in the background of AM. So AM is available material range. That say material match. So we have to check only is there any the material matches for our product application. Does the product design fit with the envelope of the hardware? That means size. So these are the questions when we will be considered while designing the part. So that is what I told you. The design has been completely revamped for the 3D printing technology. Can the product functionality improve when applying the product design modification like this, like part customization, lightweighting? That means our use of internal channels. So this will be of based on topological topology optimization, the functional integration, and the other things will be up part consolidation. And we are also having the use of surface structures. See here, the use of designed surface. The surface can also be critically manufactured using additive by the combination of material and the process parameter like heating and the energy that's supplied at the particular part, and use of multi-material and gradient material also possible. So this makes a question on the present present method of design. So here we are taking upon different strategy or the tools that being used in the development of a product that can be manufactured in a 3D printing technology. And see, what you are seeing is two different scenario. One will be the present, suppose present design of parametric optimal design. So all the parts will be designed for its manufacturing and the proportionate, so that the machining will be easy. Rather, what you are seeing in the right side, it will be of even a root-like structure, and you can see that this is for the thermal optimization, so for the heat transfer, how it will be. So to make the heat transfer effective, even the structure need not to be in the regular shapes, so like this, so that it can be distributed evenly and smoothly. Rather, what here you are seeing is some part will be in in another state. Rather here from the center, it is moving towards the outer in a smooth flow of thermal heat radiant. So the topology optimization is the technique or the tool being correctly used for manufacture the design of products in the foreground of additive manufacturing or 3D printing technology. So it will be used to lighten the product structure and the component, and it is used to develop freeform shapes, customization, and it also used for mechanically optimized part and part combination. So this is what the advantage of topology optimization when it is being used with additive manufacturing of the customization and geometric complexity. You will get a higher effective product. And this is another technology being used, or a technique being used in the 3D printing. So when we print material, we will go by layers, and so that here what you are seeing is a time spec topology optimization techniques being used to design your product, so that what you are seeing is a half ton of a bridge that being printed by a machine. Okay, so this kind of structure and structural building methods together can be evolved when it comes to the present 3D printing technology, and you can see that. So the other, as already I told you, the material choice is being completely revamped, and here what you are seeing is a functionally graded material and being controlled for a connectable microstructure, so that the strength and any mechanical properties can be customized at a regional range or even at a point. So this is completely suitable, and now all the parts can be thought of manufactured in a functionally graded material. Rather earlier, with this functional graded material being considered as a very costlier process, because how to consolidate the material being will be under question. Now it is being realizable using 3D printing technology, and you can create a part independent of material size. Rather, for a chosen material, we can customize the structure controlled for necessary mechanical properties, including surface qualities and surface requirement, or heat transfer requirements, or structural requirements. And here what you are seeing is conforming to the lattice structure. So you know that in any topological structure we apply loads, and the loads being detected for its stress flow, and the material which is less stress will be removed, and the stress portion which is closer to the set references will be retained. And when you retaining that, if you are using a lattice, that means a cube to be considered, then you will end up in a integrated, completely a the configuration as well as structure, both will be optimized here. So this is what the impact of topological optimization on the AM product. So it completely avoid including the joints and the other aspects. So there are a number of tools available. You can have a note of it. So for the 3D printing design, the topological optimization tools are being introduced by even very high-end software providers like Tessal System, given your Tosca, and Altair is also giving Siemens NX11 also having these options to design a product for the additive manufacturing. So the other possibility of design being in generative design, and you can see that this is the load I have to This is the ground constraints, and I can evolve your material starting from the any one of the point from the forward or reverse. So this is what in a generative design. So it uses algorithms or AI technology to evolve the structure in the using the topology and selection of the size of structure and the connection. So this is another, it gives an interactive design, and so that it can be a little more, effectful in terms of human, human thought process involvement in the design. Right. And this is a lattice structure you can consider, as already told you, when we do the topological optimization, you can remove the material in a square cube so that finally it will end up in a structure. So the lattice might be in a honeycomb or it may be in a square shapes, so that it will give a higher strength for a low weight. So strength to weight ratio will be more when it comes to lattice, and this is possible with a design and the things. So now the design also to be that the complete a change. So now I am not able to apply a load and then find the stress reflection or so on. Rather, now the design theory or the design equation, which are all for homogeneous and continuous, for a continuum structure, cannot be directly used. So that is why we need to think on an alternate method of design. And you can see that this is an existing manifold for the a thermal process. The thing is, even you can optimize the internal geometry at a macro level. So these are being the boundaries to find out the flow of your material and other heat transfer links, so that this complete a square block of manifold can be now be open, and this will give a chance of being more heat heat effective, and the cooling effect also very high, as it has a open surfaces more. And with this background, and we know that now the frame focus will be up not not a material size, rather it is a part reduction or part consolidation is the question. And it also how we are designing the part for the functional requirement in terms of topological structure and the graded materials. Okay, so now the question being when it comes to the design frame, it is not a separate part of a configuration design and the structure a part design. So here the both part and the assembly has to be considered together, so that wherever possible I will combine the part and the functionality while functionality being maintained. So the here there are a number of procedure are being investigated by the scholars, rather than only the configurational design independent design of configuration, and then converted as a structural design. Now it is being together, so that you can see that an assembly with no locking or pin that is being manifested in a single set. And here is you can see the witness. This is the complexity of original part, and after being adopted this assembly and part consolidation procedure, a methodology, you can see how simple the system being designed. And And you can see the effectiveness in terms of material, in terms of process, or in terms of functionality. So this is a procedure, and you can see that. First, we will this part consolidation is a process of considering the function integration, and then a structural optimization. If that the solution is being met with expected output, that will be finalized. Otherwise, we will keep going on the iteration, considering the process constraint from the in terms of additive manufacturing methods or the materials. So this is what the things being. And in the foreground, obviously a CAD model being there, and the topology optimization will be the one that will be used in the part consolidation and the function integration. So this is what the final thing that a design procedure that will be adopted for things like integral, structural, and configurational design. So in the structural design, the topological optimization will design, including the material composition and the gradings, so and the strength, etc. So you can see the workflow of things. So we will have the model, and then we will use CAE and the topological optimization, and based on the AM constraints, and we will get a CAD model, and that model being converted as a geometrical code and manufactured in a single shot, including integrated assembly and even a functional part as already shown. And this is being a case study, and I've taken a very simple object. It's a casing of a cube satellite. Okay, and the question will be up how integratedly I can make this component without any joints. And what you are seeing is the final product here. So with this background, I would like to conclude the discussion, stating any 3D printed product design will look into the assembly logic analysis. So this is the thing we must consider rather than earlier design for assembly. Now we will go for assembly logic analysis. How I can assemble the part with minimal joints without affect the function. So this is one step we have to add in the design and manufacturing of any 3D printed product. Second thing will be partitioning methods and optimization in support of your assembly. How I am going to see, you can see this cube can be partitioned in many different orientation and different perspectives. So that has to be analyzed and finalized, so that I will make it in a minimum joint and minimum manufacturing time. Then the interlocking design and optimization. If the partitions are being finalized, each part will be manufactured separately, and when it comes to interlocking, and you can see that these white parts. So only have 1, 2, 3, 4 numbers of joints. The whole assembly is able to fixed. And there are a number of scenarios you can consider. So that in a concluding note, I would say integrated structure and configuration. Noticing integration of subsystem is being the things for consider while designing any product in the future, so that it can be manufactured easily using additive manufacturing technology. So with this, I would like to thank all the participants for your kind listening. Thank you, sir.
Dr. Kannan sir, it was excellent show by you. I really enjoyed your show. Right from the beginning, you brought all the comments of 3D printing. Thank you so much.
Yes, sir. Thank you.
Now you can unshare the screen, sir, so people can ask questions, sir.
Yes, please.
Yeah, I am Ravindranath. I have asked us a very small question. Can
Yes.
we install one 3D printer along with the computer or laptop and do design at our home? Is that possible?
Sir, for designing, you need not to have any 3D printing printer. There are now, independent softwares like, CAD modeling or, ANSYS kind of things for, finite element analysis. Now we are having a software system, a standalone system that I already listed, few of, softwares that is, given by vendor like Tessals. Like they are the KTM software manufacturer, so they have a separate software for 3D printing design and coding, so that you can independently purchase and design it. And that why I am saying that it is independent. Any part that is made in CAD model can be converted into any of the additive manufacturing file formats. There are number of file formats like STL is one. Rather now we are having the 3MF, then AMF. There are number of files are there, so that it is independent of machines and independent of things. Rather, any design required only your product functionalities and the load requirements that comes
Thank you,
from
sir.
the
Only
operational.
one doubt is there. What is the cheapest 3D printing facility available in the market now?
Even we can get a 3D printer for 12,000 rupees, sir. From Amazon you can order.
Super. Anyway, I saw that the manufacturing by that GE Aviation company. So
Yes.
our DRDO also must be doing similar activities in India.
Yes, sir. Even NIT Trichy having a 3D printing facility. They are doing all metal printing.
Oh, super. Thank you, sir, for the excellent presentation. And we have given highlights of the 3D printing applied for design, why that optimization is possible. It is a super presentation which I have heard so far by Institution of Engineers. At our Trivandrum Center also, we used to have this Institution of Engineers presentation. But it is all on, earlier it was online, now it is physical model. So anyway, I am attending almost all Institution of Engineers presentation. Thank you so much, sir.
Thank you for your appreciation, sir. Thank you.
Okay, sir. Anyway, it taken a lot of time and pain to make us understand what is all about 3D printing. We have only very abstract idea only. Okay. Thank you. Thank you very much.
So,
Friends, sir,
we
you can
have-
unshare the screen, sir. Unshare the screen so people can ask questions. They will come in the gallery.
Here. There is a question, sir. Is it
Yes,
a
sir. Please ask. Please ask.
3D printing technology is latest one or it is going to be upgraded?
Definitely you will be move on in upward trend only, sir. See, till 80s, people thought that only a plastic material can be used in the 3D printing. After 80s, late 80s only, the metal being considered in the 3D printing. Now, even very thick 3mm sheets are being cut and then laminated to get the very complex and very high functional products. And I hope that it will be definitely being improved to use all the materials as well as the technology in terms of re-engineering of part or reverse engineering of the existing product will be completed. So that is where it will move.
Is there any possibility for manufacturing this technology in India?
Sir, come again. In between, I'm not.
Possibility for manufacturing this 3D technology printing machine in India?
Yes, sir. Actually, I do not know about the all over India scenario, but in terms of my knowledge and the centers I visited, IIT Chennai has a very high facility with 5 technologies of 3D metal printings, and in Trichy NIT they have 2 kind of 3D printing. 3D metal printing. So it is a very nearer, so that I visited, and if you also want to get benefit out of it, you can contact them. So it is there, sir. I hope that in some other IITs or other engineering research centers might have. I am not sure. I visited only. I have the acquaintance with these 2 centers, IIT Chennai and NIT Trichy.
This technology is used only in limited areas.
No, sir. I dispatched. What are the different technologies are being explored, rather than only implement fusion deposition. There are a number of technologies are being in the role. So I don't think that it is for a limited application, and that is why I given one example of a complete engine, right, being designed and manufactured in the year 2018. Something 900 parts is reduced to 16 parts. So that means I hope it is not limited to some areas. Rather, any parts with any functionalities are being manufactured. That is what.
Thank you very much, sir, for your high presentation.
Thank you, sir. Thank you.
Thank you, sir. Very nice. Also, can be superimposed for the manufacturing. Where are the more stress, we can do more material, like on cap and so on. That was very nice. Designing and other things, we can rightly superimpose the simulation design into the product.
Yes, sir. Yes. Yes.
Very nice presentation, sir.
Thank you. Sir. Thank you.
Everything is very nice.
Yeah.
Thank you, sir. Wonderful.
Thank you so much, sir. Thank you.
Thank you.
Participants, if you have any questions, you can ask, sir. Otherwise, you can move to the next agenda.
Dr. Kannan, sir.
Yes, sir.
Yes, sir. Sir. Good evening.
Good evening, sir. As you have shown one presentation, one gift item like that,
Yeah.
Products are now displayed in all the shops, Chinese products.
Yes, sir. Yes.
Gift items, they are manufacturing heavily by using this 3D printing technology. From
sir,
India, I think it is from China only, not in India. No, most of the shops I am seeing a lot of decorative or some gift articles.
Yes, it is not there, but now that as the technology is grown up, there's manufacturer are pushing hard in Indians to get exposed to the 3D printing technology, and surprisingly, in Tirunelveli there is a 3D printer. He design only customized kits. So people are started ordering into that shop with a specific requirement, and they have a CAD designer, and they will listen to the user what kind of features they want to have in their toys that are being manufactured, and will come up, sir. Definitely the factory industries are started considering 3D printing technology. The toy industry definitely will go very soon, And now we are talking about even a rocket engine manufacturing. So will come up.
Thank you, sir. Thank you very much.
Sir, if you have any requirement data, customer data, we will manufacture. We have a 3D printing.
Sir, good evening, sir. Anand, sir.
Titus sir, thank you.
Very nice presentation.
Thank you, thank you. Thank you. நீங்க கொடுத்த opportunity தான்.
Sir.
இல்லையா? Sir, I would like to thank my friend Dr. Titus from Ramakrishna Engineering College Trichy for connecting me with IEI Trichy local chapter.
It's my pleasure, sir.
Thank you.
Thank you, Karan sir. It was an excellent show by you, sir. Really imparted a very good thought on 3D printing. He gave a lecture, webinar on government of all 3D printing. Really enjoyed your presentation, sir. Thank you so much.
Thank you.
And we'll move on to
I have a request, sir. I have a request.
Yes, sir, please, sir.
Any of the member want to have a customized toy by the children or to gift someone of the loved one, we are there to give you a toy.
Right, sir. Thank you, sir. Thank you, sir. Thank you, sir.
Okay. You can tell your.
Yeah, sure, sir. Sure, sure. So we'll keep in touch, sir. We'll do a lot of. We have got a lot of from your talk. You understood. We have got a lot of experience 3D printing, and it is an emerging technology. We will make use of you. We will call you, invite you for more occasions and future. That's what. Thank you so much. Participants, if you have any queries, otherwise we'll move on to the next agenda. Dr. Kevin is there? Dr. Kevin? Okay, I'll announce the next week's program. Dr. Kevin is supposed to announce the next week's program, and he's busy with some program, it seems. And next week is we are going to celebrate the world, best woman engineer award celebration. That the best woman engineer is under the process of selection by the committee. That will be announced that the best engineer will deliver a talk on her choice. Next week it is on 7/3. We will be circulating through WhatsApp as well as email to all our members, contact our people. I welcome all of you to join with your friends for next week's program. That will also be online or in hybrid mode. I welcome all of you. Now move on to the next agenda. I call upon Dr. Titus, our committee member representing elected division, who is a person who connected our Kannan sir to us today, to request you to propose vote of thanks. Dr. Titus, over to Dr. Titus.
Yeah, thank you, sir. Thank you. Very good evening to one and all gathered here.
Before moving on to that, I want to tell Mr. Dr. Kannan sir, there are a lot of appreciation chat box for you for your presentation. Dr. S. Karupaswamy, our past chairman, congratulated your efforts and he has thanked you. Very nice presentation like that. And Pranesh Geji, he very nice presentation, professor, like that he has told. And Sridhar Sanmugam, he has told nice presentation, sir. And I told SK Swami, our Karupaswamy, Dr. Karupaswamy, first chairman, has congratulated you. And Dr. Madavalan is a senior teacher from BHL. He has also congratulated you. Like that, a lot of appreciation for you, sir. Just sharing you. Now over to Dr. Titus, sir, please. For what of that?
Okay, sir. Okay, sir. Thank you, sir. Thank you. Very good evening to one and all gathered here. I take this opportunity to deliver the vote of thanks on behalf of IEI Tiruchirappalli Local Center. It's my pleasure that I'm happy to deliver the vote of thanks. And first of all, I would like to thank today's chief guest and the speaker, Dr. M. Kannan sir, who is a professor from mechanical engineer from Francis Xavier Engineering College, Tirunelveli, and also my best friend of mine, for giving this wonderful presentation on this revisit to the product design and manufacturing in the foreground of 3D printing technology, which is one of the emerging technology nowadays. Everybody and every manufacturing industries are focusing towards this 3D printing technology. So this topic was very interesting and very useful for today's engineers as well as the industry peoples. So Sir has given us a very good presentation and explained in detail about with suitable and various example, practical examples. So once again, I take this opportunity to thank today's speaker, my friend Dr. M. Kannan sir, for your valuable presentation, sir. Thank you, sir.
Thank you, Dr. Titus, sir, for excellent interventions. So, with the permission of our chief guest, Dr. Kannan, sir, shall we call off the day, sir?
Yes, sir. Thank you.
Yes, sir. Thank you so much, sir. We'll keep in touch, sir. We'll do a lot of programs in future, sir. With we'll use your vast knowledge on this field, sir. Really, we enjoyed your program, sir, today. Thank you so much, sir.
Thank you. Thank you.
Nice in meeting you, sir. Good night, sir. Good night, sir. For the participants, there is a provided that the e-certificate link is feedback link is provided. Participants can fill and you will get your certificate in your email inbox. I request all the participants who are interested in getting e-certificate, they can fill the form, sir.
இங்கதானே அந்த சாமியாரை பார்த்ததா உன் மாமியார் சொன்னாங்க. ஆனா இது அப்படி யாரையும் காணுது. ஆமாமா, நான் தனியா அவங்க கிட்ட போய் விசாரிச்சப்போ இங்கதான் எங்கேயோ பிரகாரத்துல உட்கார்ந்துட்டு இருக்கிறதா சொன்னாங்க.
ஒரு 2 நிமிஷம் வேலை ஒண்ணு இருக்கு.
Yes, sir. Hello. Hello.
Yes, sir. Somebody called any requirement, sir?
I am Ilango here. I
Yes,
have
sir.
not Ilango. I am Ilango here. I have
Yes, sir.
not
Please tell, sir.
received my certificate last.
Okay. Hello. Yes, sir. Mr. Vellala, are you talking, sir? Please tell, sir.
Certificate I have not received, sir.
That you not did it, but you fill the feedback link.
Yes, little bit late.
No. Feedback link is there. Still, it's in chat box. You can fill it, sir.
I have
Feedback link is available in chat box. You can fill it. We got certificate. Kumar is filled. We got the certificate. I also tried. I also got a certificate. Did you try?
I already submitted.
Submitted. Then wait for a few minutes, sir. Then if you're not coming, tell me. Just for a few minutes, wait. If it is not coming, please tell. Oh, sir. Requesting the testing law. Around the testing law, what about the testing law? That is the testing law.
Hello. Hello.
Yes, sir. Mr. Vellala, did you get the certificate or not in email box?
Certificate I have received, sir. I am last week certificate I have not received, sir.
லாஸ்ட் வீக்
22nd.
போடுங்க அந்த அந்த வாரத்துல தான் முடிச்சோம். லாஸ்ட் வீக் சர்டிஃபிகேட் கிடைக்காது இனிமேட்டு. இந்த வாரம் ஏதாவது பிரச்சனை இருந்தா சொல்லுங்க. இந்த வாரம் இதுதான் வெயிட் பண்ணிட்டு இருக்கோம். நாங்க ப்ரோக்ராம் முடிஞ்சு 15 மினிட்ஸ் வெயிட் பண்றது இது ப்ராப்ளம் தான் சால்வ் பண்ணுறதும் we are waiting. இந்த வாரம் இஷ்யூ இருக்கா உங்களுக்கு? இந்த வாரம் கிடைச்சதா இல்லையா உங்களுக்கு சர்டிஃபிகேட்? எனக்கு கிடைச்சிச்சு. எனக்கு வந்துருச்சு இன்பாக்ஸ்ல. உங்களுக்கு வந்துருச்சா? சார் வெள்ளாள வந்துருச்சா சார்? இந்த வாரம் சர்டிஃபிகேட் வந்துருச்சா?
வந்துருச்சு. Received.
வந்துருச்சா? ஓகே, leave it. Thank you.
Thank you.
Sir, shall you close the program, sir?
Okay.
Sir? Hello? Hello? Hello, sir?
Hello.
Hello, sir. சொல்லுங்க.
Sir, meeting close பண்ணலாமா sir?
Hello, participants, we are going to close the program. Anybody have any issue, please tell me. Otherwise, we will close the program. We can close it, sir.
ஆறு பேர்